let's just go back to the beginning. When we're creating a graph, first thing we do is make sure we have our axes. Then what's the next step? Label it? Label what? Label the axes.
Oh, and are they segments or are they going to continue growing?
These are going to be axes. Okay, so what do I need to do to indicate that this is an axis? These are axes. Okay, arrows. Okay, Karen, did you say that again?
You have to determine your independent and dependent variable. Your independent variable is your x-axis, and your dependent variable is your y-axis.
And you must know what those terms mean to be able to decipher which goes where.
Okay, so in our Say-All investigation, what was the independent variable? What was the thing that we did not, was not the responding one? What was the one we should put on the x-axis?
Temperature.
Temperature?
That's what we were supposed to graph.
According to the
Per the directions and
For the directions, it was.
Let's look at the directions and see what our directions say. Make a bar graph of temperature of the dish versus the individual crystal size. Okay? So temperature is our independent variable.
But I believe the verbal directions were different than the written directions.
Okay, well, I'm just gonna go by what's written here, so what I have. And then what is the dependent variable?
The size of the crystals.
Dependent on the temperature, yes.
Okay, so crystal size depended on temperature, right? Okay, did we measure the temperature in degrees?
No.
So do we have a unit for temperature?
No. Yeah.
So this is just a label. So should we indicate what end of the axis is cold or which end is hot? So how should we do that? So over here, should the origin be cold or should the origin be hot?
I would say cold.
Does it
Yeah.
progress?
I personally think it can go either way as long as you don't go cold, hot room. As long as it goes in order, you stick with that order.
Okay.
So like if it starts cold, then room temperature, then hot, you're going in progression. Or if it starts hot, then room, then cold, you're going in progression in the other direction.
Very well said as a science teacher. That's very well said as a science. Math teachers always start with the smaller and get larger. So, but either way would work, especially if you're in science.
So I'm gonna label this cold and this is hot. And temperature, I'm gonna say of the petri dish, just to be clear. And then in the middle, we can say room temp. Okay, so whenever we looked at this in our table and we made these graphs, a lot of us, and I didn't read the directions whenever I was going through it either, so I made the mistake too. In my mind, I was graphing time and crystal size, that initial crystal size, which is dependent on the temperature, right? Okay. So we're going to go ahead and do it like this, and then maybe we can revisit that other part later. So when I have my dependent variable, my crystal size, I was to plot them according to whether it was in a cold petri dish, the room temperature petri dish, or the hot petri dish. So I graphed my 3 points, and then I graphed my average or mean crystal size, correct? And then I was to make a line out of those, or a trend. Okay, so let's go back to that crystal size. What was the smallest crystal size you
Fine.
Okay, for clarification, you said trend, so we want a line of best fit, you don't want to connect the dots.
You can connect the dots, but eventually we're just trying to see, does it increase or does it go up and down? We're just trying to see how it fits, because this is not a perfectly scaled x-axis.
Okay,
So-
it was just, that you said trend, so I was just thinking of a line of best fit, scatter plot, was where I was going.
trend line.
Okay, all right, so then,
Okay, sorry. So, but we do need to figure out a scale for the crystal size, because you did take, absolute measurements on those crystal sizes, correct? Okay, so what was this, as accurate as you can, absolutely accurate, I'm sure. So, what is the lowest crystal size you got out of all three of your trials? Smallest crystal size? 0.3 centimeters, okay? 30 millimeters. Anybody get smaller than 30 millimeters?
We have 3.67
3.67 millimeters, okay? That's pretty small. I'm just gonna make a note. 3.67? Okay. I'm gonna just say 3.6. Anybody get smaller than 3 millimeters? Okay, what is the greatest crystal size you have?
18
18 what?
millimeters.
Anybody get larger than 18 millimeters?
I thought it was that over there.
Yeah, but we have 60.
You have 16 millimeters?
60.
60
Oh,
millimeters.
are we talking cold?
We're talking in any of them. We're just trying to figure out the scale for our y-axis. 60 millimeters. Okay, let's stay in millimeters. Okay, so it looks like our range is 3.6 to 60, so our y-axis, what should we start with on our y-axis? At the origin? Should we just consider that a 0? Okay. What should we make our top? 60? Okay. So let's be clear, this is not graph paper, and I'm just throwing it down there. I'm not doing this super accurately right now, but I could in a minute. Okay, so I'm gonna plot my 3 points for each temperature. So just give me some cold temperature. Huh? 30 millimeters for cold. Okay, I'm gonna make it cold right here. 30, okay, what are some more? Cold temperatures.
7 millimeters.
Each of you had 3 measurements.
7 millimeters.
Cold petri dish.
Yeah. 30.
I need you, okay, let's
7
make this
millimeters.
7 millimeters. Thank you.
6 millimeters.
7,
6.
6,
3.
I have 4 measurements. That's all we got in the whole room.
6.5.
I need them all.
Oh, 5.
You had 3 measurements.
6.5. So the 6, 6.5, and 7.
Okay.
4.
4 millimeters.
I'm just reading the directions.
The written directions were given in the local directions.
Okay. Any more? Okay, let's go to the room temperature petri dish.
8.
8.
9.
5.
8.
7.
5.
7.
7.
8 again.
Several times for the room temperature, okay.
10.
Any more?
10.
10? Okay. More measurements for the room temperature crystal size. Okay, let's go to the hot petri dish crystal size.
5.
I got a 9.
millimeters, okay?
8 millimeters.
9.
13. 6.
4.
5.
4.
Okay.
7. And a 5.
13, okay.
6.
What else we got? Yes.
I think that we should maybe stop for a second and talk about measurement. Okay. I'm holding
We're off.
a regular ruler. My finger is about as wide as a centimeter. How many millimeters are in a centimeter? 10. So those are the itty marks in here. So we realized that what they measured was, they moved the decimal the wrong way, basically. They thought they were measuring in centimeters and they weren't, which is fine. Because 60 millimeters would be how many centimeters?
6.
Did anybody have a crystal this big?
No.
Okay, that's like 4. So, you know what we're measuring now?
Yes.
Okay.
Okay, so we've plotted all of these different points. And this is not a perfect graph. Our measurements were 3 crystals out of maybe hundreds in your Petri dish. So this investigation, this graph is just to give us a relationship between the temperature of the Petri dish and the crystal size. Because this is not going to be some perfect linear equation, right? Because this is, we're determining a trend out of this rather than a perfect graph, right? So we have all of these points here, except that one. I'm going to ignore that one. We have these here, and we have these here. So what do we observe about this graph? What can we observe about this graph? What is increasing?
Crystal size.
As the temperature increases, the crystal size increases.
Could you say that again?
As the temperature increases, our independent variable, our dependent variable, the crystal size is increasing also.
So
Well,
what,
actually, it's the temperature.
No, because it's going from cold to hot. It's going from cold to hot, reading from left to right. The temperature is increasing.
What?
Bigger.
The largest crystal is
No,
on
no, so
top.
we're, take away that.
Take away that
Oh,
outlier
I
because
thought
the
that was-
measurement was
oh,
wrong.
Yeah, we, oops, there,
so maybe it would help if I plot kind of an average, right? So if I'm just gonna take the, well, not even the median, yeah, the median. The mean is the average, and since I'm not calculating, I'm going to eyeball the median here, here, and about here.
Really?
In what grade? It should
I'm going to just kind of draw the line across. So what do you notice about the slope of that line?
It's positive. It increases.
Positive.
So, Tim, does that support what you said?
Yes.
So
As
could
the
you
temperature is getting hotter, the crystal size is getting hotter, that line that you drew is going up. The slope is increasing as you're going from cold to hot.
Okay, so what you've just done is you've written part of an analysis section of a laboratory. So when you describe that graph, you have verbally composed your analysis. All that analysis is a verbal description of your data. And this data shows us that the relationship between temperature and crystal size is that they are directly related. When you increase temperature of the Petri dish, you increase the crystal size that grows in the Petri dish.
And so the math in that is you have a positive correlation from a scatter plot. And a positive correlation is as your independent variable increases, your dependent variable increases too. So
Did y'all
that's
hear
the
what
math
Karen said?
vocabulary in the scatter plot and the positive correlation.
And trend line.
Okay,
That's
so
it.
let's back now to the other thing that we talked about, which was, what was the other thing y'all grabbed?
Time and size.
Time and crystal size. So let's look at that. Let me draw my x-axis. Some of y'all grabbed that. So which one is this? The independent or dependent? This is independent, which is,
In this case, it would be time.
okay. And what are the units
In
of
seconds.
time?
Seconds.
Yeah, in seconds.
Okay, then over here, what are we measuring or recording on our
Crystal
y-axis?
size.
Dependent and milliliter.
Can we use the same scale we used on the last graph
Yes.
for crystal size?
Oh, for crystal size?
Yes.
Yes or no?
Actually, the last time with Martin, we found out that the one was an incorrect measurement, so we still
Good
going
point, Agatha. So we could change our range.
yes.
We see that the highest one was a little bit less than 20. So we could go from 0 to 20 and maybe spread out the y-axis scale, okay? So 0, and this is in millimeters. So let's say if we go by 5, 10, 15, 20, is that okay?
Yes.
Okay. Okay, so we have time and crystal size. Yes?
It wasn't crystal size, it was the time that, wasn't it the time that the crystal first formed?
Yes, that's what we're gonna be plotting on
That's the
time.
time.
So then
The time.
the crystal formation.
It's still the crystal size.
Time
That's the time
to
that
first crystal.
And then we
I'm
did,
guessing myself.
and then we
The
did,
size.
Because you didn't- you didn't
That's
measure it.
the time, Martin.
right, but we didn't
That's
measure
what, you
the
did
first
measure
crystal.
the crystal size. You didn't measure the crystal size of the
When it first
first
formed.
crystal. But there is a correlation between the time to first crystal and the crystal sizes that you ultimately end up with, which is what we plotted with.
It wasn't in the instructions.
Okay, so let's come back.
Yes.
Time to first crystal and crystal size. So time is in seconds. Let's do our scale. Oh my goodness, we have forgotten something major on this last graph. What did we not put on it? What is the title?
Crystal size of a temperature. I don't know if that's
The name of the
the
experiment.
Relationship.
I have a question.
What is your?
Okay, well, I always just tell my students, cause they struggle with the title, they're like, I don't know. So I just say, connect both the titles of the axes with the word and it works, fine. You don't need to get super, creative or crazy with the title, just
So what do you
this and
suggest?
this. I say crystal size and temperature of petri dish. I don't even use verses because I don't know. I mean, maybe I should, I don't know, but I just say crystal size and temperature of petri dish. Is that, is that correct?
I was gonna say relationship between temperature,
Good.
petri dish temperature and crystal size.
Yeah.
Sean,
You never know, it's like,
I'm sorry?
say that again, relationship?
Relationship
yeah.
between, between petri dish temperature or dish temperature, if you wanna make it short.
Okay, guys, listen up
And
to what
crystal
Sean's saying.
size.
Petri dish,
Temperature and crystal size.
and
I like how you kept the variables in order.
what's that?
The variables in order.
Yes, I totally did that on purpose.
What order? What order?
That was not just happening. That was planned.
Independent to dependent, the way the
So
graph is
let's
set up.
take what we
Hang
did
on just a
on that
minute,
graph.
Laura, hang on just a minute.
Yes.
She said she liked how he kept the variables in the name, in order, and I asked what order, so tell them what order?
From the independent to the dependent, the way we chose to graph it.
Is that
Okay.
required in a title?
No, but it makes it easier to understand.
one came before the other, the temperature affected the size, so you
Good.
said that the cause and effect.
Okay, so let's apply that when we're doing crystal size and time.
Crystal size and time?
Mm-hmm.
Sorry, what's the one on the
Time.
the x-axis?
Time is the X.
Like,
In seconds.
back, oh, time, so it'd be the relationship between time and crystal size.
Just time.
Or time, elapsed time and crystal size.
Elapsed time of what?
And when the solution is poured to.
The formation of the
Yeah.
crystal.
It was,
It's gonna sound like one of those like science articles you read and I don't wanna read. Relationship
But, so I'm still stuck on this titling thing, I don't know why, but I feel like when you read, papers, scientific papers, and you look at all their graphs, they don't ever say relationship between, they don't go that far, they just give you the axes, because you don't, when you say relationship between that, I mean, you're assuming that there is a relationship.
Yes,
So you can't
yes,
really-
because you're graphing it.
I would imagine that if you're looking at something from a scientific journal, the assumption would be that the audience reading it is other scientists who probably can make the distinction that, okay, this is probably what it's explaining. But in terms of like middle school kids, when we did any sort of graph for like math, if we didn't label it, they had no idea what it was.
And I think that
They would
that's
just think
probably
everything should be a bar graph, or
As
everything
So
should
you're
be a
saying we
can
need
make
to
it for the kids.
consider our audience then?
Definitely.
Yeah, you have to consider the audience and something like that, because, yes, if you give a bunch of scientists a graph that just shows X and Y and just the titles on the bottom axis, then, yeah, they'll figure out what it is, but if you give it to a bunch of 12-year-olds, they're gonna be like, I don't know what it's
So-
looking at.
So what I hear you saying is that this is a little bit redundant based on that this is,
Not
this is a
redundant.
graph.
It's just, I don't, yeah, maybe too in depth, but I do see your point. You have to hammer that it is a relationship. If you're graphing, you're
But
doing
does
a
this make it
relationship.
wrong to add a relationship between? Okay.
But there may not be a relationship.
Right.
In some scatter plots, there is no relationship.
Right,
Yeah.
so,
In this case, there is.
right.
But even if there is no relationship in a scatter plot, when you're using a scatter plot, you're looking for
Trying to
your
see.
correlation. So in that instance, if there's no relation, you use a correlation between this variable and this variable.
There's no correlation.
Would your title say no correlation between these variables?
Yes.
See, that's what I'm trying to say. I mean,
You could
because
also
a scatter
change
plot is
relationship
supposed to
to
show
comparison.
either a relationship or not
Okay, that's
relationship.
good, Sean. Comparison.
Yeah.
Oh, there you go, comparison, that's a good word.
Okay, Sean, comparison between, I
Alright,
just want you to say,
okay, hang on, cause mine, when I graphed mine, I did it backwards, so. Yeah, relationship between time to first crystal formation.
and? If you're
Oh,
gonna say,
and crystal size, I'm sorry.
Results at Christmas size.
okay, all right then. Is this ready to go, to add our data?
You said something.
you need to scale.
Okay.
So we need a scale, okay. What, so can we start at 0 at the bottom of our?
Yes.
0 seconds, what's the longest time for crystal formation cemetery? Anybody get over a minute?
Oh,
Minute and a
a
half?
We had
minute.
almost
60
2.5
seconds.
minutes for
Two
the
and
boiling
a
one.
half minutes,
We
okay.
got 60.
Are we talking room temperature or which?
It's a large.
Oh,
large
we had
is-
2 minutes and 27 seconds.
2
For the-
minutes and 27 seconds, anybody have greater than 2 minutes and 27 seconds? So how should we do our scale? Okay, we have it in seconds, so what should be the high end of our seconds?
2 minutes and 30 seconds.
How many seconds is that?
That would be 2 minutes and 30, that would be 150 seconds.
150 seconds, so what do we do with our scale?
Well, what we did is we went by 5-second increments.
Okay, I'm asking what we are gonna do on this graph.
That's how it counted, there are 19 of us in here, so. The other 18.
You just go to what? 2.5 minutes, so 150 seconds. In increments of 30 seconds, 30, 60, 90.
Well, if you look at your,
That's what I'm
but you need to compare your lowest second, because if your lowest second is
Yeah.
like 1, you can't.
That's by range.
Okay.
I did one by 10.
What do you think?
Answered my quota.
I think 10 would be. I think 10 would be good, right?
10 what?
Seconds.
What, okay, 10 seconds what?
10-second increments, so you start
Like for each of these
at,
lines or?
start at 0,
So each little line is 10 seconds?
I skipped a line.
every other line.
Every other line.
So each line is,
5 seconds.
Yeah, each one is 5 seconds.
Yeah, I'm gonna do each one.
so you're saying that this is 5 seconds, this is 5 seconds, this is 5 seconds?
No, each side.
Every other.
5,
So
10,
what is this big line going to be then?
25.
Brenda?
25 seconds.
Okay. Does this work for everybody?
Yes. Okay.
Yes? 25, so what's this one?
No, I started counting each individual one.
Is that enough?
What do we got?
There's 150, is the last one, and it needed to be bigger? Okay, so what we're gonna do then is we're gonna make a collaborative graph, a group graph to see the relationship between time of first crystals and crystal size. So during our next investigation, just at some point during the investigation, one person from each group, or each of you come up and plot with a pen, just put a dot for your 3 mean crystal sizes. The time to first crystal, and then your mean crystal size for each of your 3 petri dishes. Okay? So you're going to have 3 data points that each of you are going to plot. Just put a dot on the graph when you graph it. Okay? And then we'll come back to it and talk about the relationship in a little while. Clear?
No, I'm
Okay, Teresa.
We're doing an experiment, but then we're gonna go back and do notes on it from an old experiment? Is that what you said?
We're going to revisit this crystal size graph in a little bit after we collect all the data. Rather than sitting here and me saying, what are your 3? What are your 3? We're going to go and do something else, and y'all can come up during that, record your data, so just so we're not blown out of our minds.
And then you'll pull it all together.
Is this clear?
Yes.
All right, I'm going to leave this right here, leave the pen on top, and y'all can watch your data.
Yes.
You do.
It's not good. I don't want to screw everybody
Where's the other numbers? Goes from 0 to 20.
Yeah, we don't have crystal size.
We don't have a, so.
Yes, to me.
Never mind. I'll figure it out.
I need you to locate either place in your binder, page 54, or in your textbook, page 62. They're identical. This one would be for, you would take notes on, I would assume, but you certainly have a beautiful color picture in your textbook, okay? This is page 54 in your binder. We gotta mark it properly. Alright, everybody ready? Everybody ready? We have a very strict time today, 11:30, boom, we're done. And you don't want to miss the last part. We have to save time for the last part, okay? Thank you. Alright, starting at the top, you have a egg carton that says cold somewhere on it. Some of you, I had to duplicate and use a mineral box, but it should say cold on it somewhere. And so the sequence for cold is a good way to use the whole rock cycle, okay? So it starts in a swamp. Fresh water, salt water. What do you think?
Fresh.
Fresh. fresh water is absolutely right. As a matter of fact, the kinds of plants that are found fossilized in coal, these are examples of the trees that we have fossil evidence of, somebody has fossil evidence of. They mostly are going to not remind you of much that's here today. Some, yes, but not, most not. And these are the ferns. And so I have a sample over here of lignite coal from the Pennsylvania coal mines. And you can see that fern frond. Yeah, this is lignite coal. It's heavier than our lignite coal. It's definitely more compacted. So in your egg carton, do you see your fern frond? And so those plants, swamp means perpetual. It stays wet. It can't change with the seasons. Dry up and fill up, and dry up and fill up. It has to be a perpetual body of water, because the plant material has to fall in and fall into the water so that it doesn't decompose. And so at the very bottom, do you see this little bitty layer right down here? Yes. That is a sedimentary rock. It is a layer, right? In your picture, in your graphic, layered sedimentary rock. Could you tell me most likely which detrital rock that would have to be to hold water, make water stand in a pool? Limestone? What's the problem with limestone? It's porous. It reacts with acid in water, weak carbonic acid in all sources of water. So limestone would not be a good rock to pool water. And shale? It is shale. What is shale made from? Clay particles. Little bitty, tiny, tiny particles of clay. So it is not very porous. It is going to, it's going to allow water to move through, but ridiculously slow. What's wrong with sandstone? And the particles are so much bigger. The difference between one little grain of sand and one grain of sand and clay is humongous compared to the difference between a grain of sand and a pebble. There's far less difference in those particle sizes than there is between the sand and the clay. So the clay forms an impermeable layer. It is made of clay, it has been compacted and lithified, and so it makes a sedimentary rock called shale. So when they search for coal seams, they are looking for plant matter on top of shale. It'll also have a layer of shale on top of the coal. It's going to be sandwiched in between two layers of shale most often. All right, so this decomposing stuff down here we call peat. So in your second compartment of your egg carton, pick up you a pinch and look at it closely. You have your magnifying glasses on there. What are you seeing? What's in there? It is detritus, but what kind of a detritus? It's not sand, it's not clay, it's not gravel, but it is plant matter. Do you see little pieces of stems and leaves and bark? Yeah. We typically use it and call it mulch or peat moss, right? As a fertilizer or to loosen up soil, perhaps.
So is that what you actually use? You use peat moss in here?
That's exactly what it is. That's right.
In Canada? Those bogs?
The bogs?
Yeah, no.
That's exactly right, yes.
So you know those plant cups?
Yes, yes.
Biodegradable?
Probably.
What was that question? I'm sorry.
The plant cups that you planted and you put it in the soil and.
Oh, yeah.
Like the
Biodegradable.
like the hanging baskets.
Okay, okay.
Can you show on the picture where that is?
Right here, this is all wheat.
Okay, that part. All right, thank you.
From the shales to the bottom of the bog or the bottom of the swamp. Okay? Alright, so it is varied. That means some other material falls on top. It is compacted. Plant matter. Compacted, squeezed, mashed. And it becomes a low-grade coal, very soft. It is called lignite. So in compartment number 3, you have a piece of lignite. Pick it up. Talk to me about its density. Talk to me about its density.
It's not very dense.
It's not very dense. Why is it not acceptable to just let children say it's light?
Weight is ambiguous.
That's referring like the weight.
Yeah. And so what she was saying when she picked it up, I would almost bet was, for this to be a pretty good sized clump of stuff, it sure isn't very heavy. So when you're looking at how big it is, and considering how hefty it is, then you're talking about density, right?
Yes.
So my question to you was, pick it up and talk to me about its density. Does it feel soft to you? Now, you're going to get some stuff on your hands if you rub it, okay? Free when you burn it. Absolutely. Or charcoal, right? So, it's kind of what it is. It is continued to be buried. More compaction, more pressure, and it begins to be more what? Dense, packed tighter, and it is now called bituminous coal. Lignite is a sedimentary, chemical sedimentary rock, but so is bituminous. Bituminous coal is a sedimentary, chemical sedimentary rock, not detrital. It is made from plant material. It is biological chemical sediment. It is soft, it is black, the major coal used in power generation and industry. It is high energy, but it also has a lot of trash in it.
What's the department that we would send you samples? Is it the mining? What is it? It's the department.
Texas Mining and Land, yeah.
Bureau or something like that, land and.
TM, I have it on the tip of my tongue. I can't tell you. Texas Mining and
Reclamation?
something Reclamation
Yeah, I think reclamation.
and Land Reclamation, I think.
Okay.
I have the address of those people because they sure do provide some wonderful teacher training like this, where you go and stay in a dorm at a power plant and you learn all about coal and you wear the hard hat and go right out there near the conveyor belts with them and you see what they're doing for reclamation, and it's a fantastic experience if you're looking for some background. And this is metamorphism. So now then we have pressure from the top, layers, buried deeper, but we also have compression from the sides. And so we have this folding and this bending, metamorphism. And so now we have a metamorphic rock. It's called anthracite. So in your box, I skipped one. Number 4, let's go back to number 4. Because what is number 4? Pick up number 4. It should be D, I think.
Yes.
D. Is it coal?
No.
No. Is it rock?
No, it's
It's a mineral. What mineral is it? So if we take this thing all the way from lignite to bituminous to anthracite, And if we continue to add more and more pressure, you're gonna end up with nothing but pure carbon. Yes, there is sulfur in it. You bet. That's called graphite. Okay? And it,
Yeah, hold on.
okay, here,
Yeah.
Well, yeah, but this is sulfur.
Yeah, that's
Yeah.
why are you?
Why, I
talking
don't
about
understand when
one?
this comes.
She's talking, this was in, okay, so this.
I was just responding to Sean because he said sulfur, so.
Yeah.
So there's gonna be some sulfur in it, we're coming to sulfur, okay?
This is right.
Alright, I'm gonna do the sequence again.
Okay.
Lignite
Uh-huh.
is turned into bituminous, is turned into anthracite. If I keep going, adding more and more pressure, more and more heat, pressure, and or chemically active fluids, I am going to end up with graphite. A mineral, pure carbon. Now, it's lost its sulfur by that point. It's got sulfur all in this, okay? But we're down to pure graphite. And look hard, because if you added more pressure and more, there would be a diamond. Do you see it in there? Is it in your egg carton?
No.
No, it's not.
But
But a diamond would be an example of another mineral, but a mineral that forms from a melt, right?
Yes.
Okay? All right, so let's back up. You see, I should have me one. G is your bituminous coal, and we call H black gold. Look at it. It is anthracite. That's it. We don't have any anthracite here in Texas. We have lignite and we have bituminous coal. Okay, and so what's about that sulfur? So, anytime you burn plant material, there is going to be sulfur that's put into the atmosphere. And when it rains, the rainwater washes out that sulfur from the sulfur dioxide that's placed there through the burning of coal. And we would say that the homes, the buildings, the fields around those places doing that sort of thing were causing acid rain. And it will destroy the finish on your house. If you have metals, it will burn plants. Yeah, mess up the buildings, all kinds of things. So there are some good things about coal, but there are some serious environmental things about burning coal, okay? And so sulfur is the real culprit for burning coal. And so over here I have sulfur reacts with iron in soils and produces this mineral. You didn't have this mineral in your box, but this mineral is iron and sulfur. You know what this is? Yeah, fool's gold, we commonly call it. This is PBS, FES, iron sulfate, and it is called iron pyrite. And so a neat demonstration for you to do is to have some powdered sulfur. You buy it at the feed store, and you collect some iron filings. My husband has a metal grinder, so I just go out there with a magnet and pick mine up. He thinks I'm out there cleaning. And so you put that iron filing in a petri dish, let the children observe it. You put the powdered sulfur, and you're reviewing chemistry because both of those are elements, right? Yes. So they could draw their Bohr models and review their chemistry, very basic chemistry. And then if you put these in a test tube, and you could never do this with your elementary students if you don't have a Vent-A-Hood, but you mix them together, and you show the children, you put a magnet over put a piece of saran wrap over your magnet, pass it over the mixture, and that magnet will pull out every little piece of iron. But you dump it back together, put them both in a petri dish, and heat it, and you will have to break the test tube to get it out. But you will have this.
how much you have to heat it?
You've got a utility melts.
Bunsen burner?
Bunsen burner.
No
Takes a
candle?
Bunsen. No candle, no. You're gonna have to have a Bunsen burner.
Bunsen burner.
What about it will heat on just a hot plate, isn't it?
Probably not.
You're not gonna get it hot enough. You're gonna have a direct hot flame, blue flame. Okay? And I do it without melting it. They're still amazed because I pass these two pieces around with the magnet and they thoroughly expect that these ought to be magnetic. And are they? Nope. And so it's a good way to differentiate between physical and chemical changes. Okay?
And the compounds.
And the compounds, yeah, the different properties. That's right. Exactly. Okay? All right, just to show you a few things about Texas and why I think that there will be some of you living close to our area. This is a U.S. map, and I know you can't see the colors real well. There's yellows over here. There's a few yellows over here along the Rockies, and that is anthracite. We have none. This is our lignite, and notice that this borders the Balcones fault line, but up on the plateau, we do have some bituminous coal, and they are strip mining it for the most part, and if you are teaching school anywhere along here, your community will have a significant population, a tax base, all that goes with a big industry being in your area of coal people. And so I've worked with a lot of schools south of San Antonio where it was expected that their teachers in science would teach about coal, provide you with all kinds of resources to do that with, all kinds of training, like bringing you to their plants, and their goal is to help you understand what they're doing, what their challenges still are, and help you to develop in children an understanding of what's good about it and what's not good about it, and what still is to be done. And so this is us. Well, that's terrible. Okay, significant number of counties affected, right? That's an outline. This is lignite, this is bituminous for us. This graphic shows, and I'm not sure that you're going to be able to see it, but this little stipple stuff right up here, brick looking, no, this little stuff right in here, that was crude oil production. And so we started out and we reached a peak, and about 2020, our supplies. Now that's not counting the new stuff that's just now being pulled from the ground through slant drilling, but we're over, and we began to depend upon our crude oil to come from the Middle East, right? And this is natural gas. Now natural gas is way up for Texas because we have found an abundance of natural gas through this slant drill process. But this is coal. And this is the year 2,200, a little bit less. We've got a lot of it, right? We certainly have a significant amount to see us out to sometime in the future. And we best be busy to find some other source of energy. And so here we are pretty much today. I think I'm protecting these things, right? I'm creating a Elmo disaster. So here's our electricity, approximate electricity today. So we live in the hill country. We have some pretty reasonable rates of electricity compared to many people. Because we live on the escarpment, close to the escarpment, we have some dams with generators, right? That's a pretty, very clean and effective source of energy. As long as it rains. And as long as you live in an appropriate place, which certainly doesn't take care of most of Texas, right? And so this is oil, this is natural gas, this is nuclear. We've not made a whole lot of headway with nuclear. And this is coal. So we are heavily dependent upon coal for our electrical needs right now. Okay? Did somebody's hand go up?
It did, but I was thinking something else, so it's, never mind.
How old is that graph?
It is not recent. I visited the big brown coal plant. It's Round Top, Giddings, no?
It's more
LaGrange.
south there.
It's close to LaGrange. That's where I went to a week of coal, and at that time, this was there. So it's, I know that this is still a significant part.
No, I was just curious because it says like other, and I was assuming that solar power would be in other, but Texas has the most, wind is what I was thinking.
Yeah.
Wind, I know we have the most wind
Right.
energy of any state, so I was curious where.
California?
Is that
Yeah,
true?
and in this particular graph, it would be in the other. And I'm not sure if somebody has, anybody know about how effective the wind for us is here in Texas? The wind?
Yeah.
There's a lot on the coast, there's a lot out west. Yeah.
What you were saying earlier about how the coal companies go to the area and supply educational resources. I have a lot of family that lives in South Texas.
Yes.
Small Texas towns. And what I've noticed as a science teacher over the years in regards to like my cousins, a lot of my older cousins and uncles and stuff work for the oil field, is that they have completely convinced them that solar energy has negative effects, that wind energy has negative effects, because they've drilled on my aunt's land, for example, my grandmother's land, so they have convinced them, because I've had conversations with my cousins about the negative effects, and they're like, well, don't you know this about solar? And I'm sitting there like, are you serious? They really told you those things? So, you know.
And I think that our job as teachers is to present both sides. You know, this is the benefits and this is the negatives. And then it's up to you.
They do it that way so those people won't take their land back from those coal people.
Sure. You know, they are making money off of
Protecting
it.
their
There's
investment.
Yes.
But I mean, would you agree that in any system which you remove some part of the system, that there's an effect? Whether it's negative or positive, there's going to be an effect.
Absolutely.
And I don't know if we've studied solar energy long enough to understand what those effects could be.
Right.
But there's going to be an effect.
Right.
Yeah.
Dr. Rennie?
My younger son he is a rope specialist, and he goes down and he repairs the wind turbines. He's in New Hampshire right now, and so he knows a lot about the wind power and all. And he said the biggest drawback from that is they have not figured out a way to store the energy and transport it that it's created.
Well, I mean, I
So-
think that that's going to require a major shift in our infrastructure and our grid
Yes.
systems, and they're just not willing to do
and they're
that
not
yet.
willing to do that. So that's the biggest drawback for that.
No one's making like banks and wind and stuff.
But I really
Alright, here's your last rock cycle. This would be what students would call the test. Are you ready?
Throw it at us, go ahead.
Okay, open your binder to page number 33. I'm sorry, no. Binder 55. And I'm going to remind you of 3 resources that I think you as teachers would best profit by using, and that is your igneous, sedimentary, and metamorphic chart. Pretty much to help children process any rock that they would bring you, refer to those charts and process with them. So you're on page 55. There is a chart that summarizes for you the very basic characteristics of the 3 rock groups, and you have 12 unknowns in an egg carton on your table. So, just like with your minerals, I want 3 good descriptions of each rock. I want it appropriate for rocks, not minerals, which and only which mineral tests can be used on rocks. The acid test, the only chemical test. All of the others are for minerals, and these rocks are mixtures of a bunch of minerals. So it wouldn't be appropriate to talk to me about their hardness or their luster or their streak or any of that stuff, right? So you're looking for the big major characteristics. Now I want to tell you about the questions at the back, the concluding questions. They are intended to guide you to the right answers. If you have missed seeing crystals, there's going to be a clue in the statement, in those conclusions, to tell you to go look at it and report the crystal size. All right? So on the front page of your data table, which would be page number 56, you see a box over there that says rock name and rock type. For rock type, just put an S, an I, or an M. For sedimentary, igneous, or metamorphic. And then attempt to give it its name. Would getting the names correct be the ultimate important thing for your children? Absolutely not. They'll get a bunch of the names correct. But should they at this point be able to recognize sedimentary, igneous, and metamorphic characteristics? Yes. Okay? Alright, so I will be available to help if you get just totally stuck. Oh wait, I forgot something. We're not taking you down to do the acid test. You just told me that the acid test would be appropriate, right? Yes. Alright, for some. So turn to number 5 on your data table, and as your first observation, write positive acid test. Number 6, right, plus acid. Number 11, plus acid. All right, you're ready. Number 11, number 5, number 6, and number 11 are all positive acid tests.
They're in the box. Inside the card that says rock. They should be numbered. They should be numbered inside the put it right there.
They're not labeled, so we have to remember 1 through 6.
Yeah. 3 observations about each of the samples, as you would expect the children to know how they look, how these were made.
But they are.
And that's okay, all right?
Number 1 has.
You'll process it.
Oh, these squares. Very small.
Questions first.
Help me. Am I trying to say? What am I saying? Like compared to this one, like C variations. This one's C. All one.
Either small increases in the shiny part.
Yes.
So they'll be increasing in the shiny.
No, you're saying that's up. It's saying why.
I've always been a woman and had shimmery aspects.
Why did they smash after the texture?
So look at this. Are there layers?
This one up.
It has a negative acid test. Right. Okay, so it would be more than likely be aqueous. We need to put our sizes in. No variation. Little to none variation in color.
So now you know what this one is. So, in the observation that they have. Well, here's an observation from one that
So it's fine, very fine. Dark.
Number one places of those charts. Or that, yeah, that's it.
Well, that's the two. That's probably one. That's still when you figure out which.
I guess. Only white people, white
This is very to Anthony, you agree with our observations.
So that's what we'll have a short one.
Named Blair.
Okay, so we're gonna start.
You prepared this one? Blair, like.
Yeah. Well, it's just because one probably
Would that be
So
it's a lighter color.
So no, what is that? Solid. Mayonnaise with vinegar. Layers? No.
Because of its size, which is would you say it's dense? It is dense.
That layering, fairly even, horizontal. Maybe made of sand, gravel, clay, shells, plant matter, so that chalky layer. Need a third, it's really smooth. So on this chart, vinegar, Only Stars have packed to be, we're gonna go fly out of here.
I'll pray twice as happy because I'm gonna do laundry.
Well, I gotta do that too.
Oh dear.
Okay, so it's fine. Probably shale. Lead plate shale. Because it doesn't have a positive acid test, so it's not a calcite.
So that's restored. That's good. Very basic as
Yeah, and she said most often we're just gonna call it shale.
Just saying it's because at the bottom it shows
These are the positive acid.
I think this is the error.
And it's always this one.
Granite, diorite, that's why it's small. I would say diorite.
Your scalpel.
I'm not a breakfast person.
It's 58.
Yes, oh, I'm thinking. So it's fraction. Need a third description.
This is number
Is it?
That's number two.
No, this is fraction.
Oh, I'm sorry. I was assuming last note. I'm just trying to find it.
It's very dark.
Observation has to be longer than
Gorgeous, there's the description.
I love like oh what is it? There's a gym being black and black.
I've got dark black and
On it.
observation.
It does fraction.
Okay, so metamorphic.
Let's call this one easier for today. We're defining physical characteristics. Okay.
Right, wait, so that okay.
So rough, that's great. Well, we know it's not good. We know it's have to be.
Well, good. You can't be metamorphic. There are no plans.
So this is more porous, even though we don't think about porous. Well, the particle size and granite is porous.
Looking more again.
That's the ones I compare like shale to sandstone.
There are even here that are here to rock type striations, that's right, you factor in
Right, I'm
that.
I'm seeing your depression and porous. So the reason I say that it's porous is because we to the calculation itself. The problem is.
Definitely,
I mean, sorry, the granite is wet, so
dark.
goes with all that water, so greater mass. I have a, like I have to take my down.
I said this one.
How many is it?
Okay, I just assumed it was porous. That doesn't sound right.
No, it's,
Number 4. Are there any bands, players?
This is
Now we have to
Need one more
find
description. Does it have a shape?
Light with color.
What are the shapes? What are those geometric shapes? Or rectangular? It doesn't look like a weird
and the gas, the curving for the gas.
Light colors.
There's two types of lawn, so.
earthy? Earth tones?
What are we pointing to?
So those crystals.
With porcelain.
I don't know the difference
And so there's nothing, so like on those sheets here.
Oh, that's different shapes.
It's crystals. So it's got crystals and the crystal size vary.
I don't know what they
See, if any of you guys
All sided of crystal.
and the color kind of varies. Sorry. H. Oh, sorry. Yes, okay. It reads right. It is preparate. That's
Initially getting a drink, but then I looked up quick.
Yeah, because that one tells me what I'm about.
The color again.
None of these say anything about crystals.
Oh, you see.
Yeah,
It does not have a color tab.
I'm looking to set a picture. There we go.
Diorites. This means that it had perceived
We're going by that
horse ring. And it's another light ring, but it's kind of in the middle.
This rock is also.
This is
It's
not.
not granite. Now, okay, do we think they would form magma or lava?
Well, I wrote them all,
Wrong.
and then I scribbled them out, so there you go.
I thought crystals, but it says.
For morning festivals,
This rock is also crystalline.
And then the blue rings that
well, that's what lets you know the difference between the,
But no, the rock colors. When the rock color versus the texture difference. So how fine grained is it?
okay, I see. So this right here.
And don't forget on your market
Diary.
That's it.
I what? No.
If you look at the, it's closer to this.
So 5 does have a positive
It's not as
aspect.
shiny, it's not as shiny, whatever, but that looks
They're gonna be like what it's,
that's what I was Let me see. So it's totally looking at but that's just one time.
You look like a proud mama listening to everybody.
I am, I'm very proud.
You listen to hear something. They're just smiling.
I'm listening to you, Ross. So good.
Free course.
Let's look at the texture. What's the texture?
Crystalline lines.
That's what we're trying
Massive, very
I have between the two.
Yeah.
It's green. See, sedimentary and metamorphic both show layers. So this does not show layers. Unless you look at this side, you can see right here. Layers.
Yeah, shells is,
If you look right here, a little bit different, like a little tannish color. Get them out there. Color blonde.
It's yeah, that's why I'm.
But it's sparkly. That's the differentiation between sedimentary and metamorphic. Crystalline, no crystalline crystal shades. Sand dunes, uneven, striations, cozy. Well, it's wrapped out with fingers by the soul. They're not like let's look at metamorphic.
But according to this thing, like, it is real. They look real.
I think it's nice. It is metal. I was sitting here, you can put it
do you know the answer to this? If I ask you a question? Okay. So.
Okay, let's look at.
Definitely not marble, but you can actually see.
Yeah.
No, right, that's the other one. I would do it wrong. I think it's but it reminds me of the parent rock for nice. The parent rock for nice. Grayson, and that is yeah, that's that's the parent idea of well, you don't know the nitty-gritty, so if you were teaching negative that was like different, and you wanted to know negative sides, negative
create the number lines and plot it. See that the negative 5 that as they're going down and they're plotting as the negative 5 comes to 4, negative 8 and it's closer to 0.
Has the same way, if we get a 9 there, and then on the number line,
So, could that be crystal? So the
Right,
day,
yes.
does it have?
no, that's the layers of crystal.
But that's all you do.
Towards the positive, I should say that. No, it's just moving more towards the positive, closer to the positive number.
But not enough. And they're all saying that's right.
With the, when you ask
Looking at it like
about to explain the positive side, you have to explain that. You can't rely on 0 being some sort of like
I think we actually have a project on this.
looking for the acid bomb. I guess we took it. She's going for the acid down. She's
Oh, no. It would just Why did you?
Well, the shed.
I think they do
Like a bigger.
This one is more fine, really
With work? So it's not, you think it is fine? You think lease was?
Sometimes compositions, they're hard.
Just check, because he said it's loosely fragmented. Loosely fragmented, right? Right? Yes.
Which is how they describe it.
Does it have a sparkle or is it shells in it?
What do we know about sediment?
There's a lot of white flags.
Sediment particles, number 9. Okay, what observations on your basic problems. Cement in there. There's sediment particles falling off. Okay. I'm fine with it. Just the way it, how to word it, but the way it's shaped is very, not all regular rock. Well, help me.
It looks like it's.
I mean, it's been crystalline.
And I think this is more, I would say this is more crystalline than having a they all can change
It did not have a hard access, so it's not a cafe.
Abundance of filling spots.
When did you have to look at that
Look at where those pebbles. Here, 9 pebbles. Load up. It's not crystally, so it's not, it hasn't been destroyed.
I mean, I know.
Look, if an abundant self, so once you guys have this, that's not a perfect key, but it may help you guys get started and not, and you have it, and 60. Yes, you have it. So wasn't sure if you anything else other, yes. Mention these numbers, so I want you guys to look at this and see if having done this, I accidentally was told you the answer.
In solution can do it.
Well, that's what we're saying, the other one was
That's
like a
I mean, it's just great to read that, but they're both saying that they're both A++. Okay, so can you see big crystals? See your sand grains or pebbles? Little pebbles or grains? Not the short bus, the limo. Yes, and I'm an estimate.
Trying to digest it, but this
Hold on, wait. Yeah, like I have piles that are intermittent, and it has a geometrical shape.
No, you'll get one. So, I already have tried, but I don't
Yeah,
Just by the
rectangular, so the orthogonal it was more rectangular than square.
Look at me when I was here. And you're wanting me to do this?
Then I won't forget. And you see the round.
I picked up somebody's pencil.
She's been asking.
I am the world's worst.
Okay, what is it?
I wasn't even writing. Yes.
I prefer 12 in the dark or
You can see shells, right? You can see shells.
Cocaine.
Cocaine? No, it is not cocaine. I'm sorry. Well, are there various sizes and shell crackers? Does it have calcite? Is it sparkles? Calcite or
Right, alright. So these go together in. So here's the thing, right?
All right, I need a heads up. How many people are finished?
Just identify or doing
Completely finished. I thought I had a group completely finished. How many people have finished with your observations, but you're working on the concluding question? Halfway done. All right. I want you to take a break at your meeting. Right? And so I want to pick up stuff when it's convenient, as soon as it's convenient. So when you finish with the box, if you don't need it anymore, we're going to pick up the break. Okay? But if you're in need of a break, just go.
Yeah, think about things you would want to ask her. You don't want to get her separated. Where are my glasses? Where are my glasses? Oh my goodness. Lay it on thick.
Circles don't have to So we deciphered cocaine.
Yeah.
Some of them you just don't know when you say it.
Okay, I'll tell you, just as soon as I find Grady, she's
So she now has readers, and she has the hardest time finding ones that work with her. Because they used to carry the ones that she used in costumes. They would have, two frames, but now, like, she can barely find her number or whatever. And she never puts but she did that too when she found it. She was like, so I'm taking all of them.
One has smaller, larger lava or magnet form?
Well, the way it's cool.
One day.
Just never what it is.
Yeah.
My sister.
I know that I'm going to have to stop wearing my contacts for a while to let it heal. But
lava is intrinsic or extrinsic.
10 years. And then if they have, it's very, very slight. And I'm pretty lucky with Dr. Hughes. Her name's Dr. Hughes. And she's one of the top eye surgeons and she's really, really good. I just, have to have that sustainable income. But my mom and both my mom and my stepdad did it, so they love it. Like, okay, riddle me this. This is a dream of mine. To wake up, look across the room and see my lollipop. Yes, that's a dream
My
of
dream
mine.
is to be able to see.
Crystals, it is
I
lava.
can see this world without my phone. Less than a foot. It's ridiculous and everything else.
What is
It's a link type.
I don't. I always get those from places.
I would say we know it's not slate.
I noticed they were not
My sister, she's one of our
But it's fine if I just wanted to watch. Oh, yes.
Very nice. don't like working out with my body.
We know it is.
Like
When I was doing it, I had prescriptions that were $100.
yeah, I have some like that.
You lose those, you break those, what?
I brought him to school for the first time. I was so excited. I went and I got his glasses and his medicine ball since they were going to steal. And at school, he had fallen out of my bag underneath one of our desks in the office. But it had fallen like behind that blue crate. I was freaking out.
Type. Well, let me just a minute more. What happened was
That's the main model.
so cool. Everyone has a different
All five of them.
I should know that I went recently. Yeah, better to use less.
What two common observations do you have in 11?
Are you having problems with like, asking questions,
There's shapes or
oh God, I gotta go 10 steps forward. And they're like, I'm fine.
At night, I get blurry. It gets blurrier at night. Especially when, like when people have like little really bright like college
this tells us that you're playing golf time. So you have to stay golf time. So we know this is sedentary. And so you have to be sedentary. Well,
they're not
outside. The Chinese, this one, and it's sedentary.
My first task that I went to I still have it.
They gave me, it was like they gave me for chowder team?
They had a cardboard and like, here's a whole bunch
No
of
shower, so
cardboard.
it can't be
They gave
cooking
me
it.
tons, like I was like having trouble carrying it all. And then they don't want to carry it. Yeah, and I was like, they were going to give me more. I was like, I was like, who's going to carry that?
He's a positive asset.
Did you go to
I did not know this last year.
It was like a sell-fest. Like everyone was trying to sell you something. I was there were not enough or descriptive enough descriptions of what was going on to know whether you were walking in to get sold something or whether you were walking in to see a lesson.
It was painted on.
Yeah.
I don't know who was maybe this was last time. Well, one on
I do appreciate that they have like samples of stuff. Like there was this one that we went into that made it sound like it was really awesome.
Because it doesn't have
Like a place you could go to, where you could find any resource you needed, and there would be lesson plans, quizzes, worksheets, and all that stuff, and it ended up being something that you had to buy. You would have to get your points and on board with it, to do it.
It says mine here.
Yeah, that's what it was. Yes, with the quizzes and like, and they weren't even good quizzes. They would go in there and really, this is fun. It's what I learned. You think about it, that's what it
Like where
Just tell us
I wouldn't even buy it anyway. I just get it online. They're like, what if you wanted to see like the color glasses cost a lot, so you know, whatever. Then it says this will stay up that way. That's not still not bad. Yeah, I was like,
What's the parent wrong? Go to your memoir.
I was thinking that's good.
These don't fit.
some things that they would go and
So what does limestone turn into? If you polish it and put it on the table, she pointed from over here.
But it is metamorphism.
Yes.
On the upside down.
because 2 and 12. Well,
All of this right here comes $3 and she was like, you should probably get what? 10 of them? She was in there, she's like, I can't believe how this is here.
There's nothing more amazing.
What's the question?
I love how she was like, come over and buy this for $10, doesn't she get the second card, and I'll trade the card to go buy this. She was like, this is like inflation stuff.
That's what I would have the only one I really like. That lady said it's Anyway, who is that? 'Cause I have never gone I have never read any of her books, so like saw any videos, like I know all those are online. I just love that it wasn't Dinah that was really I like working with her. But she obviously she talked a lot about her classroom, and she had her like actual notebook that she showed us. She talked about how yes, there is a lot of things that you have to do in order to make this work. It's not just like you have to get your students to pay attention. That's where I get confused. You have to be confident and be diligent about what you're doing.
Okay, there we go. That's where I get confused. Because it's just the first
blew my mind. So you get a color piece of paper and you get clear packet tape, dry erase board for every single thing on the back of your science paper. And then all you have to do is
and then like $1.
This is on your science paper. It goes around all the time. It's not an extra resource. It's not going to take up any more space. And then all you have to do to replace it is another piece of paper or packing tape to keep a science notebook together. Duct tape binder. What works on composition notebooks and spirals? I was like, how did I never think of that? It's not like ingenious. It's not crazy difficult. How did I never makes me wonder how in the way that she was using pieces of paper that students were bringing, like stuff they could bring in for school supplies. It wasn't like cardstock or anything like super crazy expensive. It was Elmer's yeah, but think about the cost of newspaper versus printing out what she's saying. That's cheap. The only downfall to it is there's extra work. There's a lot of work by it. You have to plan your class.
experimenting with like little things.
You did it for like 30 seconds and then.
Well, you know, it's not very
That's yours. This was in your book. You picked it up, you did it, and I just said it right
She was like, I've been doing this, we found out how to constantly just she was probably the first person to
Alright, I need to check, how many people are finished?
Yeah.
How many people are within just seconds of finishing, perhaps just on some conclusions? Okay, I think we're close enough. We're gonna check for most important, sedimentary, igneous, or metamorphic. And then just as a side note for you as teachers to see that you processed. You didn't just look at them and know what they were, but you used your resources and your knowledge base, and you could figure most of them out. And really, that's what you would do with children. You don't just tell them what they've got when they bring you something strange. You say, let's figure it out, and you know the resources to go to. Okay, so number one. Okay. All right. I'm going to put my hand up and forget. Number one, I want to call those people. I'm going to use, this is not me, but anyway, here we go. Johnny, number one, what type of rock is it? What type of rock? It is an igneous rock. And Tamara, what is its name?
Salt.
That is absolutely correct. The salt. Number one was the salt. Teresa, number two, what type rock?
Sedimentary.
Sedimentary is correct. And its name is Donna. Not here, right?
No, I am. I'm Donna.
You're Donna. Shape. Donna, glad to meet you. All right. Agatha, number three. What type rock?
It is an igneous rock.
It certainly is. Did it cool fast or slow? Brenda.
Fast.
How did you know?
It was glassy.
Good. And its name is Margaret.
I'm saying, wait. Yes.
Correct. Number four. Brenna. What kind of rock is number four?
Sedimentary.
That is correct. And its name? Zanik?
Zurich.
Zurich? Conglomerate. Conglomerate. What a beautiful name. Andrew, would you please tell me about number five, what type rock it is? Metamorphic is correct. And Martin? What's its name?
Marble.
Marble. It was crystal-like and it gave a positive acid test. Crystal-like clued you to which chart? Metamorphic. And the positive acid test then allowed you to eliminate the other. Number six. John Anthony,
Yes, ma'am.
what kind of rock is it? Type rock?
Sedimentary.
Good. And the name of it, Beatrice, is?
Limestone?
Limestone is great. Number seven, Tim.
Number seven, the type of rock is metamorphic.
Correct. And its name, Christian, is?
Seven is schist.
Seven is schist. Now, everybody listen just a minute. I would accept schist or gneiss. They're both foliated, right? So, I'm going to show you this. You may have seen it. This is Rowan's, a wonderful sample. This is very definitely a mica schist. Can you see this? All the little schisty pieces of mica laying parallel with one another. Your sample was sold to me. I didn't see it. It arrived. I just put it in the boxes as a gneiss. So do you see the difference that this one allowed more compaction, more heat, more chemically active fluids to allow all of this quartz, all this white band in here is mostly quartz. When you look at it from the top, you see this, right? Which certainly is a schist. So I think it's kind of confusing as a sample. All right, and so you're going to get some better samples of gneiss, some hometown Texas samples of gneiss, and you're going to get some pack saddle schist, which is a mica schist. Not quite this beautiful, but it's still very schisty. Okay. All right.
The nice thing that I like about this, that even though it looks like one thing, it's actually that. Can you see that symbol? Is okay. So most kids, when they pick it up, they're going to hold it like this and try and go this way. But you can kind of reiterate that you should look at the sample from all perspectives, because this is the outside part, and it's like, okay, they broke it open, and so that's what the innards are. And so, you know,
her innards are also quartz.
So
right,
I like having this as a throw-in. I probably would put this like in an 8th grade sample for them.
Right.
That is one that is more challenging versus very obviously schist versus nice.
Yes, ma'am.
How would an ELL student handle nice and nice?
To be quite honest, I would have modified to not even include the names, perhaps, of anything like gneiss and schist. Yes, it's okay for sandstone and, you know, the very common and the very obvious, but I wouldn't give them the really challenging examples. That's just me personally. It's not necessary. It's not something that's really critical to their educational pursuit. On the test, it's sedimentary metamorphic.
Okay, I'm also thinking of the word nice, like this is nice. Nice.
It is nice looking.
It is nice looking. So I think that could be confusing too, but I like your answer. Sedimentary.
Igneous and metamorphic is the big
That's
purpose.
a big concept, okay.
Right, and to look for the characteristics that tell you that.
Okay.
They're gonna give them pictures. You know, there's gonna be one that's layered, there's gonna be one that's banded, there's gonna be one that's obvious, great, big, and individually identifiable crystals. They'll even tell you what they are sometimes. Okay, and where are we? I like this. Lisa, I am on number 8. What kind of rock was number 8? And it is called Moriah. I think that's it.
Oh,
Moriah.
number 8.
It is igneous as tungsten. What was so unusual about it when you picked it up?
It was very nice, lightweight.
Lightweight. But if you say light for its size, you're now talking about its density. And sure enough, it will do what in water? It will. Number 9, Karen.
I have type rock is 7 carat.
Good. And its name, Sean?
We put sandstone, and then underneath it in parentheses we put Arcos, just because it does have a lot of red, so we thought maybe it has feldspar in it.
I think the red in yours is primarily iron, is my assessment. But I understand that you were reading in the book, and when it said that
Yes.
pink color,
Yeah.
it's okay. All right, and number
So it is sandstone.
10, Agatha, what type rock?
Number 10, I have as igneous.
Igneous is correct, and its name, Brenna, is?
Diorite.
Diorite is a 50-50, right? 50% light, 50% dark? Is that what you're saying, you see? And it's certainly an igneous rock, and I'd have to look at your sample, because it may be mostly 50-50.
It does.
When I purchased it, it does?
Yes.
I'm gonna go back and look at the box that I loaded your boxes from. I think you're right. I think they sold it to me though as a granite.
Right.
Is it
graded
a
diorite?
No, it's just different coloring, right?
Remember on the igneous chart, across the bottom, it goes from mostly white, light colored minerals to mostly dark.
Okay.
And so granite is in the mostly light, pink is light.
Okay.
That's why you're saying 50-50.
And the ones in the center, which is diorite, is 50-50. I think you could easily call it diorite.
Or granite.
Or granite.
Okay.
Okay, and number 11 is Lisa.
11?
What type rock? Sedimentary is correct. And what name did you give it, Martin?
I can't say that right.
Yeah, you can.
Coquina?
Coquina, or you could have said the collective word for anything that gives a positive acid test, which I've used with young children, is it's a limestone. There's a bunch of different kinds of limestone. Teresa, number 12, what type rock?
Metamorphic?
Metamorphic is correct. And what name did you give it? Zerite?
Oh, slate.
Oh, slate, okay. All right, would you have your trays ready for us to pick up? And you need to pick up your stuff because Roland's fixing to be Santa Claus. Thank you. All right? Wait. We're going to pick up. Roland and I are going to pick up, but you're going to listen right here about this graph.
I would love to do this, but I can't do it with one data point. So whenever you get to the stopping place, please come on and put your data on the table.
Okay, you're going to hand me all those little pieces. So you're going to just bring it back.
Where's your data?
There were two places that show up.
Page 37.
Thank you, girls.
One of them was apparently out of town, the other one had some family.
We're gonna do
I was like, I want to be out of town.
She's asking for that one.
Okay, what?
I got it.
Yeah. You have it? Because there's very simple after you start
Okay.
And then like almost everyone shows work with your
She was there.
but maybe it's absolutely.
I'm here. So basically, us three.
So maybe
That's all they did.
I
I was saying you and one. They basically took like 3 people and were like,
Okay.